All right, you guys. So we'll be learning about combinations of transformations, which basically means we're going to be doing more than one transformation at a time. So we might translate, then reflect. We might rotate, then dilate. We might reflect, then rotate. So we're going to be doing more than one transformation. So go ahead and turn in your nifty packet I gave you to example one. We're only going to be doing two transformations at a time in here, which this one has we're only going to have, yes, two transformations at a time, which this one has three. So go ahead and cross off that last transformation. We're not going to do all that, so just cross that out real quickly. So this is given with points A at 0, 0, B at 8, 1, and C at 5, 5, rotate it 90 degrees counterclockwise, then reflect the figure over the x-axis. So we're going to rotate, then reflect. Okay, which, since I already have my pre-image points, I'm going to go ahead and graph those bad boys. Look at that pretty triangle. Okay, now the first thing we're going to do is rotate this thing 90 degrees counterclockwise. So I need to think about what is the rule for rotating 90 degrees counterclockwise.
221 bus is here. It will be leaving in 1 minute. Bus 221 will be leaving in 1 minute.
Sorry for the interruption. I did not think that was happening. But anyway, so let's continue on. But anyway, so we will be rotating 90 degrees counterclockwise. So let's think about that. What is the algebraic rule for rotating 90 degrees counterclockwise? Holy hot dog, it is, you guys. So the rule when we do 9 degrees counterclockwise, which is the same as 270 clockwise, is negative yx. So all that means is x and y will flip-flop, so they'll trade spots, and the brand new x, or in this rule it means the original y, will change signs. So let's figure out what our very first transformation will be, which this is not our final image, so we're going to have like two sets of image graphs and points. Okay, there will be like the first image and then the final image or the second image. So the final image, when we reflect over the x-axis, is ultimately where we're headed, but we have to do this 90-degree counterclockwise rotation first. But anyway, so let's set up our points. So I've already set it up, so my brand new points that are located in the new x spot will turn the opposite sign, which is negative. So x and y will flip-flop. So I'm going to put my x's over here, so bam. And then I'm going to put my y's over here and change their sign. So 0 can't really be negative, so if that's like irking you, that's just 0. So we have our points at 0, 0. Then 1 transformed into negative 1, and 5 transformed into negative 5. So those are our image points for our first transformation. And don't forget, since it's the image, I'm going to throw those fancy little primes on there. So now that I have my points, I'm going to graph them, which I tend to dash the in-between transformations because that is not what we're trying to get to. So that's kind of like the transformation that's going on behind the scenes. But you don't have to dash it. It's just for me, I like to let me know that's not the ultimate end transformation. So after we have rotated these things 90 degrees, then we're going to reflect this thing over the x-axis. So to go from here, we need to reflect these things over the x-axis. So again, we need to think about the rule. So what's the rule for reflecting over the x-axis? You are correct. The current x's will stay the same, but the y's will change. All right, so technically the rule is x negative y, but when we write the algebraic rule up here, what we're going to be doing is we're trying to figure out what we could do to our original points to get here, to get to the reflection. We know from the original point to the rotation, it goes negative yx. But if we go from the original points, our pre-image points, and simply do x negative y, we won't get our final points. Okay, we're doing the x negative y to our most recent point, which in this case is this one. So I'm going to ignore this xy real quickly. So what this rule tells us is that our original x stays the same. Okay, so my original x in my new point, my original x in this point is a negative y. So negative yx, this coordinate will stay the same. So my rule, this is going to stay as negative y. And then the current point in my y spot will change signs. So x is currently sitting in the y spot, so that will change signs. So since we're picking up from this rule, we're not picking up from this rule, we're picking up from this one. Okay, so again, my x stays the same and my y changes sign. So in my brand new point, negative y is in the x spot, so negative y stays the same. And my current y will change signs. Well, my current y, x is currently sitting in y spot. So x is just going to change to negative x. So what this tells me, you guys, is if I were to transform all my points from the original, so from my pre-image, if I applied negative y x, I could ultimately get my final image. Now, if this is confusing, all we're going to be doing is taking our most recent points and keeping x the same and changing y. Okay, but again, this rule tells me if I flip-flopped all my x's and y's from the original and changed the signs, I would ultimately get my final image points, which is really cool. But I'll kind of show you that in a little bit. So again, my x's stay the same and my current y's will change. So if I look down here, so now we're applying this rule to reflect over the x-axis. So my current, which again, this is what we're doing, but this tells us what we're doing to get from the pre-image to the final image. So let's just ignore this right here for now. Let's look here. Okay, so my current x's are all going to stay the same. So what are currently my x's in my purple image points? They are 0, 1, and negative 5. Or sorry, 0, negative 1, and negative 5. Okay, but then the signs of my y's will change. So when I set this up, I'm going to fill in my x's here, which I can't remember yet. So I put my x's 0. Remember, there's no such thing as a negative 0. That does not exist. So we have 0, negative 1, negative 5. And then all the signs of my y's will change signs. So all these will change signs. Remember, that negative doesn't mean it just goes negative. It means it changes signs. So 0 will stay as 0, which I know it says negative 0, but it means 0. 8 will transform into negative 8, and 5 will transform into negative 5. Okay, so if you guys see, these will be our final image points. And since this is the second transformation that I've gone through, I throw on the double prime. So you guys see double prime, double prime, double prime. Holy hot dog, right? Okay, so to get from the first prime, or my first image points, we kept y or x the same and changed all the signs of y. But now, so this rule up here that I was trying to explain tells you what you could actually do to get from the original pre-image points to my new or my final image points. So this tells me if I took my pre-image points and I flipped them and changed the signs, guess what? I would get these points. So like 0 is not really a good one to do, but if I flip 0, 0, it's still 0, 0. And if I change both of the signs, well, 0 doesn't change signs. So that's not really a helpful example. So let's look at the next one. So if I flip x and y and change the signs, so 8 and 1 would transform into 1 and 8. And then the opposite of a positive 1, positive 8, is negative 1, negative 8. So whoa, right? So this rule ultimately tells you what you're going to do to get to your final point. So that's why we do this rule. All right, and then again, our points switch spots. So 5, 5 changes spots, which 5, 5 will turn into 5, 5 if they switch. Doesn't look like they've changed, but they secretly have. They're like secret little ninjas. Okay, and then both of my signs will change. So 5, positive 5, and positive 5 will transform into negative 5, negative 5. So that's another way to look at how to get these points. And now that we have our final image points, let's graph those things. There we go. So this thing has rotated 90 degrees counterclockwise and flipped over the x-axis. And bam, that's where that would land. Cool beans, right? All right, nice job, you guys, on example 1.